I'm going to try and exercise a little steerage or captainship, which is simple goals. What simple goals would lead to benefit to users or others? And I suggest that tokenizing and linking each token to an explanation of the meaning of the token, or otherwise indexing it, would be useful. And I'm very interested to hear other people's ideas of what useful goals might be.
I would argue that for typical LaTeX markup as described in Lamport's book and the LaTeX Companion, one could set up relatively easily a small set of grammars. You might need one for the book style, one for an article style, and so on, which have different levels of headings permitted, that would allow you, in conjunction with a tokenizer, to write a parser that could validate that an input document did conform to that grammar. And that would be useful. And I'm not sure that anybody has done that. But it wouldn't be bad to have such a thing. And my TechPretty printer essentially assumes that the document does conform and produces indented output that reflects the logical nesting. And when that output looks peculiar, you realize you have a mistake in the input that needs to be repaired. There are also additional tools like delimiter checkers. Some editors provide some limited capability of checking for balanced delimiters. I have a standalone tool called CheckDelim that does this very extensively and very generally, that I use a very great deal. Every tech document and every BibTeX file that I post on the web, which now amounts to millions of lines of text, has gone through these tools to make sure that there aren't unbalanced braces and other such simple mistakes. And I use them routinely, and I urge our students to use them, but of course, they may have different goals in life than writing correct input. Many of them simply have the view, I've got to get my term paper finished or my thesis finished and get out of here. And they'll do whatever it takes to do that without worrying much about what the input looks like.
I'd like to put a gloss on what Nelson said, which I found very, very useful, which is that we can think of a parser or a checker as a systematization of a well-chosen collection of examples. So if you have a well-chosen collection of examples, that should define the parser and the checker. And the collection might have things that are invalid or are flawed in some way, in which case that should sort of be tagged. And it's interesting that that point of view sort of puts you into the machine learning situation. The machine learning situation is where you have thousands and thousands of examples of handwritten digits. And they're tagged with the correct values, and half of them are used as training data for your machine learning system. And then the other half are used to test the machine learning system. So simply having a collections of examples is perhaps a good way of systematizing a parser or a checker. And thinking on the fly, if you're a journal publisher and you've got thousands of articles, you might say, well, let's look at all these articles when they came in and when they came out, when they were ready for publication, and see what they have in common, what we can accept, and what problems in the inputs we should be reporting to the users straight off. That would be a sort of modus operandi for creating a parser checker for math or physics journals, for example. And that fits in with the sort of setting up of a community of practice. I'll stop again.
I'd comment that such tools do exist because the way most publishers work these days is they actually hand the job of converting author input off to firms that are in lower wage areas of the world, notably India and Eastern Europe, and say, send us back an XML file and a PDF file for this journal article. So those individual companies then have had to develop software that deals with exactly this problem. But because they're in competition with one another, these tools are all proprietary and you have really no access to them. In the United States, the National Science Foundation for grant proposals accepts documents in a variety of formats, but in particular for PDF, they run some sort of PDF validation on the proposal and reject it if it doesn't conform. Similarly, the archive.org, that's ARXIV, it accepts user contributed tech files and at their end turns them into PostScript and PDF and rejects them if that process fails, and at which point the author then has to fix them. So there is validation going on routinely. It's just that it's not routinely accessible. It would be nice if there were public domain tools. For example, one would like a PDF validator, and there are such tools, but they cost money. And they come from different companies, and so they do different things and have different degrees of reliability. We would like to have this sort of thing for HTML and for LaTeX input. For HTML, actually, there is a free online service from the Web Consortium, and most of my HTML pages have a little link in the top right corner that will, with one click, take me to that site and validate the page. So after I've edited, I make sure that I haven't introduced silly errors. But there's nothing like that for LaTeX that's freely available that I know of.
The validation, sorry.
Yeah, for validation. I mean, the validation that people have at present is, can LaTeX consume this document and produce a PDF file?
That's what I was going to say. At Archive, the validation is essentially, does their own processing fail or not?
Yes, what one would like instead is a tool that does not attempt to produce any output whatsoever or interpret the meaning of the glyphs, but merely examine the markup and ensure that it conforms to some reasonable grammar that's easily understood by authors.
Yeah, like the HTML you mentioned, or there's also such a tool for Fortran, which is intended to find things which are problematic, even though it's valid code, which is a bit of a different problem, but still quite useful.
Right, that tool is called FTN Check, and it was developed by a computer scientist at Fordham University in New York that I visited several years ago. Yeah, such tools are very valuable, and I make sure we have them on all of our systems because I want our users to be able to quickly find errors with the help of software tools rather than having to painfully read their text line by line, trying to figure out where there might be an error.
When we get to 7:30, people can gracefully leave if they want to leave, and they can gracefully stay if they wish to stay. I'm pleased with the discussion. I've learned a lot. It's clear there's a lot of work to be done, and there's a lot of prior art. And what happens in other areas, the practice in other areas, has to be understood, but it can't be just mimicked because of the peculiarities of our own area. So I think the next step on this, as far as I'm concerned, is to understand the state of the art, to understand the present state of the art, and also to understand the present state of the problem. And a small piece of information, I had a quick look at an Overleaf page found when I searched for LaTeX syntax tracker. Their editor has a LaTeX syntax tracker, but it doesn't handle user-defined macros. And that's a very interesting area. Let me just say that. There's one more thing I want to say, which is that for many people, I suspect, LaTeX encoded mathematics, perhaps to be displayed by MathJax, is their primary introduction to LaTeX rather than the whole document. And a syntax checker for MathJax could have special benefits and certainly has a special place in things. And it perhaps fits in with the profusion of LaTeX editors available for HTML. So I'll stop at that point, and I encourage anyone who wants to comment, particularly those people who haven't had a chance to speak yet, to come in.
Jonathan, I have a comment, if I can, regarding the checkers. Sorry for the additional person or thing to our meeting today, but somebody has to watch him. So I think that it's equally important, along with these checkers, to also have documentation of the checker. So for me, somebody that doesn't have a lot of background in LaTeX, I like rules, but if it's some piece of code that's implementing the rule and just changes my input, then I don't necessarily learn from them very well. And so I think it's equally important to, as rules, say if we created a checker or if we advocated for somebody's checker because they're obviously already out there, I think that it's equally important to document the checker so that people can learn from it rather than just using it blindly.
Absolutely. If you like, you can say, what would happen if a human expert looked at this? Now let's try and reproduce that experience using software. Have I got you right there?
Yeah, thanks.
Yeah, an issue that beginners with LaTeX face is they're not sure just what does a typical document look like. And so in our sample theses for our department, I arranged for there to be a small step in the Makefile that identifies essentially the top level markup, the front matter and the sectional headings and so on, strips that out into a file that's then typeset verbatim. So they can see what the LaTeX structure looks like without the content of all of the paragraphs. And that fits on a page or two, even though the sample theses might be 50 or 100 pages long. And I think it's important for beginners, just as Kernahan and Ritchie demonstrated in their first book on the C language, that you show people what does a minimal program look like. And their minimal program was a program that printed hello world. It's only 3 or 4 lines with headers. And people I think have recognized that it's really helpful to have examples of what does a complete input stream look like for things like a book or a chapter or an article or a bibliography entry and so on. So that they can say, oh, well, now I understand the structure. My job is now simply to fill in the blanks, fill in the values of the paragraphs.
I sort of think that we've got a way forward coming out of this, which is a well-chosen collection of examples of LaTeX source files and LaTeX snippets. There may or may not be such. Even if there is such, things grow, things change. And they can be chosen for their correctness and they can be chosen for their flaws. Certainly, I remember when I was teaching, you have marking schemes and you have the correct answer and you have various incorrect answers with indications as to how many points should be taken off for the various errors. And that sort of thing is used in the Open University to provide automated marking, automatic grading of routine exercises. So finding a well chosen collection of LaTeX source files so some correct and some with flaws, would be, if you like, the test data for any parser. So we could say, take all the examples in the LaTeX book that Lamport wrote. Does the parser do the right thing on all of those examples? And this relates to, I think it was a couple of weeks ago, Tech by Example, the various Tech by Example books. And it rather seems to me that there's a sort of, at least the triangle. There's the validator, there's the user experience, and there's the collection of examples. And those three things together, along with documentation, so that's a tetrahedron, if you like, seem to be things that will, so to speak, support each other. You know, I'm sitting on a chair. The chair has got 4 legs and it provides a stable platform for me to sit on. I wouldn't be able to sit on a mono stool, a stool with 1 leg. And I think that a parser that doesn't have examples and user experience and documentation is similarly incomplete. Although we may have to start by creating or finding an example and then growing things.